Since 2020, artificial intelligence has emerged as a transformative force across industries, and cybersecurity is no exception. While cybercriminals and threat actors are upgrading their arsenal with more sophisticated AI-powered cyber attacks, it has become essential for organizations to enhance their cybersecurity infrastructure by utilizing AI-powered cybersecurity options. But what are those AI-powered cybersecurity options? Hello folks, and welcome to this edition of Cyber Intrigue presented by Dramagine. In this edition, we are going to discuss about applications of AI, or advanced machine learning in various domains of cybersecurity. Before jumping to individual applications of AI, we must understand various AI methods that AI-powered solutions utilize to achieve the desired results. These methods are machine learning, deep learning, and natural language processing. Machine learning algorithms learn from data without being explicitly programmed. In cybersecurity, machine learning is used for tasks like anomaly detection, malware classification, and predicting potential attacks based on historical data. For example, a machine learning model can be trained on network traffic data to establish a baseline of normal behavior, and then flag any deviations that might indicate malicious activity. A subset of machine learning, deep learning uses neural networks with multiple layers to analyze complex data. Deep learning excels in areas like image and speech recognition, and is increasingly used in cybersecurity for advanced malware analysis and identifying sophisticated threats. For instance, deep learning models can analyze the structure and behavior of executable files to detect zero-day malware. Natural language processing enables computers to understand and process human language. In cybersecurity, natural language processing can be used to analyze text-based data like emails, security reports, and dark web forums to identify potential threats, phishing attempts, or emerging attack trends. These three AI methods are used individually or in combination within various AI-powered cybersecurity options that we are going to discuss in this edition. Let's start with AI application in communication and network security. Threat detection and prevention is one of the most prominent applications of AI in communication and network security. AI algorithms analyze network traffic, system logs, and user behavior to identify anomalies and potential threats in real time. Machine learning models can predict future attacks by recognizing patterns in historical data and emerging threat intelligence. AI-powered intrusion detection systems can identify sophisticated attacks that signature-based systems might miss. AI-powered malware analysis and detection is highly recommended AI application in cybersecurity to fight against threats like ransomware attacks. AI can analyze the characteristics and behavior of files to identify known and unknown malware, including zero-day threats. Deep learning models can dissect malware code to understand its functionality and potential impact. AI-driven endpoint protection platforms can detect and block malicious software before it can execute. Another AI application in communication and network security is phishing detection. NLP techniques can analyze the content, sender information, and context of emails to identify phishing attempts. Machine learning models learn to recognize patterns indicative of phishing, such as suspicious links or urgent language. AI-enhanced email security solutions can filter out sophisticated phishing emails that bypass traditional spam filters. Implementing these AI applications for communications and network security will help organizations fight against various threats. But any threat or incident detected should be reported, recorded, and handled in order to avoid any immediate or future incident of breach. This brings us to our next cybersecurity domain, security operations. Under security operations, the AI applications include vulnerability management, security orchestration, automation, and response platforms. As part of vulnerability management, AI can assist in identifying and prioritizing vulnerabilities in systems and applications by analyzing code, configurations, and patch history. Predictive analytics can forecast which vulnerabilities are most likely to be exploited. AI-powered vulnerability scanners can prioritize remediation efforts based on the risk level and potential impact of vulnerabilities. AI can automate parts of the incident response process, such as triaging alerts, analyzing the scope of an attack, and recommending remediation steps. Machine learning can help security teams quickly understand and respond to threats. Orchestration, automation, and response platforms often integrate AI to automate responses to common security incidents. With all the security controls in place, an IT security infrastructure still depends a lot on human behavior. To understand how AI can help against security lapses caused prominently due to human behavior, let's explore AI, applications and identity and access management domain. Identity and access management involves various human actions as part of user identification, user authentication, user access provisioning, and controlling user access on secured assets. AI can enhance authentication processes by analyzing user behavior and detecting anomalous login attempts. Behavioral biometrics, powered by AI, can provide a more secure way to verify user identities. AI can enforce adaptive multi-factor authentication based on the risk associated with a login attempt. AI analyzes transaction data and user behavior to identify fraudulent activities in real time. Machine learning models learn patterns of fraudulent behavior to improve detection accuracy. Financial institutions use AI to monitor transactions for signs of fraud and prevent financial losses. AI algorithms can also analyze historical records of user roles, access, and access utilization in order to determine as acceptable access usage by different user roles. Identity and access management solutions powered with AI capabilities can help administrators implement a strong role-based access control with automated access recommendations, SOD conflict predictions, and access certifications. The AI applications we discussed so far are mostly reactive defense mechanisms, which takes action after certain event or action or incident has already happened. AI-powered solutions also provide proactive and preemptive options, ensuring that possible known vulnerability or threat, which leads to a breach or an incident, never occur. Let's uncover AI applications in security assessment and testing domain for these proactive and preemptive options. Security assessment and testing is a domain which focuses on identification and detection of vulnerabilities, defects, and issues in a solution before that solution is introduced to mainstream system. As part of threat intelligence and predictive security, AI helps security teams predict cyber threats before they occur using threat intelligence models. These systems analyze global attack patterns, dark web discussions, and evolving malware tactics to help organizations proactively strengthen their defenses. As part of testing automation, AI helps in test case generation based on application behavior, self-healing test scripts that automatically update when UI changes occur, scalability to handle large code bases and complex applications, and enhanced accuracy in bug detection compared to manual testing. Going one step further, AI provides application in software development security domain to ensure secure software and coding standards are met during the software development lifecycle. AI-powered code scanners not only identify poor coding practices, bugs and defects in large code bases based on code base purpose, code input and output data, code entry and exit conditions. It can also identify unpredictable and unforeseen failure, breakdowns, and infinite loops conditions, and provide remediation suggestions. Few advanced AI solutions are also supporting secure and standardized complete codebase generation from start with just text description of the codebase from developer. With so many AI applications in cybersecurity, it is hard for organizations to choose the suitable options for their IT infrastructure, and they face a critical question of how to prepare for the AI adoption. Implementing AI solutions for cybersecurity requires a strategic approach to ensure effectiveness and alignment with organizational goals. The first step is to assess your current security landscape. Conduct a gap analysis to identify vulnerabilities AI can address. Evaluate existing security tools and determine how AI can integrate with them. Define key cybersecurity challenges such as threat detection, incident response, or fraud prevention. The second step is to identify AI use cases applicable and suitable for your organization. Prioritize AI applications based on risk assessment and business impact, focusing on security goals. The third step is to choose the right AI solutions. Select AI models trained on relevant cybersecurity datasets. Ensure AI tools comply with industry regulations and privacy standards. The fourth step is to build a skilled team. Train cybersecurity professionals in AI-driven security operations. Encourage collaboration between data scientists and security analysts. Invest in AI governance to ensure ethical and responsible AI use. The final step is to plan AI implementation or adoption roadmap. Implement AI in phases. Start with pilot projects to test AI effectiveness. Gradually scale AI solutions across different security layers. Hope you enjoyed this edition of Cyber Intrigue. If you have any suggestions for improvements or topics on which you would like to see similar videos, please share those suggestions in comments section. Look out for more upcoming intriguing videos. Persuade your cyber curiosity. Get Cyber Intrigue.
Dramagine,